Now the second problem for you is, yeah, I'll just change this. If, let's try again. So here you are given the volume of the solution in terms of milliliters, and then here you will have to now express this volume, that is milliliters, in terms of liters, and then you will get the answer. So now the second problem here is, it says if 2 moles of a salt is dissolved in, 2 moles of salt is dissolved in enough water to make up the solution to okay, 500 ml. Find the molarity of the solution. Find the molarity of the solution. Molarity of the solution. Right? That's it. So the solution here, you are directly given the number of moles of the salt. So you write number of moles of the salt is, okay, it is 2 moles. And then the next thing is the volume of the solution, right? So the volume of the solution here, volume of the solution is 500 ml. 500 ml means 500 milliliters. You have to express, now change this into liters. Once again, if you want, you can use this unit factor to change milliliters into liters. You know, 1 liter is the same as 1000 milliliters, isn't it? So this ml and ml will get cancelled. So finally, 500 divided by 1000 is nothing but 0.5. 5 by 10, 0.5 liters. So now your molarity here, molarity of the solution is equal to number of moles of the solute or the salt, that is 2 moles, divided by volume of the solution, that is 0.5 liters. If you simplify this, you are going to get, alright, so this is same as 20 divided by 5. This is moles by liter. It is, am I right? Okay, 5 4 times. It is 4 moles per liter. This is the answer. Now the next problem for you to work out, maybe let's say if there is a small twist. A solution is prepared by the third one. Okay. A solution is prepared by dissolving 100 grams of sodium hydroxide in enough water to make up the solution to make up the solution to 10 liters. 10 liters. So find the molarity of the solution. Find the molarity of the solution. Find the molarity of the solution. That's fine. And now, in fact, this is also a very simple one. You are given the mass of the salt, that is sodium hydroxide, in grams. Now to find the molarity, you have to know the number of moles of the salt. So this 100 grams of sodium hydroxide is equal to how many moles? Now 100 grams of sodium hydroxide, that is, you will have to divide this 100 grams, that is number of moles. See, number of moles is given by mass of the salt, given mass, that is mass of the salt divided by molar mass of the salt, molar mass of the salt, molar mass salt. So now here the number of moles of sodium hydroxide is going to be mass of the salt given here. You can write given mass of salt, that is 100 grams, 100 grams divided by the molar mass of sodium hydroxide. You all know that the molar mass of sodium hydroxide is sodium, it is 23, oxygen it is 16, hydrogen 1, so total it is 40, right? This is the formula unit of sodium hydroxide, 40. Now when you express this in terms of grams, 40 grams is the molar mass of sodium hydroxide, so 40 grams here, G and G get cancelled, so it is finally 2.5 moles, 2.5 moles. So when you write the answer here, you write number of moles of sodium hydroxide as 100 grams, that is equal to 2.5 moles, and then the volume of the solution, you're directly given the volume here in terms of liters, that is 10 liters. So you will divide 2.5 by 10 liters and you will get the answer. And the answer here, and if I am not wrong, it is 0.25 molar solution. You can put it this way. Alright, that's it. The third one. And then the fourth one now. The fourth problem for you here. So you're going to see some twists in every problem that is coming up. So one by one you can see the twist. So like the fourth one for you is find the molarity of the solution prepared by dissolving (53 grams of sodium carbonate in enough water to make up a solution to make up the solution to, alright, solution is to 800 ml. Very interesting. So let's see. Here, to find the molarity, the expression is number of moles of the solute or the salt divided by volume of the solution in liters. So this time, you're not given the number of moles of sodium carbonate, but you're given the mass of sodium carbonate, that is 53 grams. You have to change this into number of moles. And then even the volume of the solution is not given in terms of liters, it's given in terms of milliliters. So you have to once again change this into liters, so you know how to do it. So let's see the first one. Number of moles of sodium carbonate is equal to, you are given 53 grams, right? 53 grams. So number of moles, it can be obtained by dividing the mass of the given substance by its molar mass. By its molar mass, right? That's it. Or if you want, you can use this unit fraction method, the same thing, you get the same thing. See, as far as sodium carbonate is concerned, its molar mass is 23, 2 plus carbon is 12 plus oxygen is 16, 3 times, right? So this is 46 plus 12 plus 6 and 3 is 48. Totally, I think it's 106, right? 40, 50, 60. 106 if I'm not wrong. Okay. So 106 grams. 1 meter is, if you divide this by 106, you get number of moles. Or this thing called unit factor, if I apply, I want the quantity here to be expressed in terms of moles. So when you talk about sodium carbonate, 1 mole of sodium carbonate is the same as 106 grams. Gram and gram get cancelled, 53 once, 53 2 times is 106. So this is 0.5 moles. Right, and then the next one is volume of the solution here. Volume of the solution is given as 800 ml, right? 800 ml. 800 ml. Now to express this in terms of liters, you have to divide it by 1000. Or you can again use this unit factor. So this to get this in terms of liters, 1 liter and a milliliter, what connection is there? 1 liter is nothing but 1000 ml. ML get cancelled. So it is these two zeros, 8 by 10 is 0.8 liters. So you've got the volume expressed in terms of liters. So finally, the expression for your molarity here, molarity is number of moles of the solute. You've got this to be 0.5 moles. And then the volume of the solution, it is 0.8 liters. When you simplify this, it is the same as dividing 5 by 8 moles per liter, right? By liter. So when you divide 5 by 8, it is 5 divided by 8. Or if you know how to divide it, put a decimal point here, again put a 0 here. 8, 6, 48. 2 remains. 0 here. 8, 2, 16. Remainder here is 4. Then 8, 5 is 40. 40. Alright, so this is 0.625 moles per liter. So this is now the molarity of the solution if you are given this kind of problem. That's it. Now the next one, problem number 5 for you is, okay, this you will work it out. Find the molarity of the solution. I'll write it here, it's right. I'll make this question number 5 now. Question number 5. Find the molarity of the solution prepared by dissolving. This time it is a different kind of a compound. It's 171 grams of sugar. 171 grams of sugar. Formula of sugar is H22O11 in enough water to make up the solution to, okay, it's 5 liters. You're given the volume in terms of liters, right? 5 liters on capital letter L. This is problem number 5 for you. Then the 6th one, it's almost the same thing. So I will skip this. Let's see. Now the next one. Okay, this is another twist now. Let's take this. Problem number 6. It says find the mass of sodium hydroxide required to prepare it is say 4 liters of 0.125 molar NaOH solution, right? NaOH solution. Very simple. So here, what you can say is you are told that to prepare 4 liters of 0.125 molar sodium hydroxide solution, what mass of sodium hydroxide should be used or dissolved? So now, here this is your molarity. The capital M here means 0.125 molar solution, which is nothing but 0.125 moles per liter is the molarity of your solution. That's it. And you are given the volume of the solution, that is 4 liters. So to find the mass, you know that number of moles of any substance is given by mass given, that is given mass of the substance divided by the molar mass. So let's see here what you are given as molarity of the solution, right? You write molarity of the solution is given to be 0.125. Okay, capital M means molar solution. Now volume of the solution. Volume of the solution is, okay, directly 4 liters, you can take 4L. Now what we are asked to find is mass of NaOH. What is the mass? This is what we need to find. And for this, what you can do is, you know this expression molarity of the solution, right? So just put it this way. Molarity of a solution, or molarity is given by number of moles of the solute, right? Number of moles of the solute divided by volume of the solution in liters. You have this expression. Now you can make a small change. The number of moles here, this is the turning point. Number of moles is given by mass of the given substance, or given mass of the substance. You can take it as X divided by its molar mass, right? Now the given substance here is sodium hydroxide, and you know that its molar mass is 40 divided by volume of the solution in liters. If you're given the volume in liters, you can write directly it is 4 liters, right? 4. And under this is nothing, you can take it as 4 by 1. And the molarity of the solution, right? So here the molarity is 0.125. So you just simplify this expression, and it's finally going to be 0.125 equal to, this is X by 40 into 1 by 4. You take the reciprocal of 4 by 1 is 1 by 4, isn't it? So finally, what will happen is, this is 0.125 equal to X divided by 40 into 4 is 160, right? So finally, when you cross multiply, your X is going to be 0.125 into 160. It is equal to, okay, the answer I've got here is something like, 20 grams. It's 20 grams, huh? 0.5 into 160. Finally, it turns out to be at 20 grams, yeah. 20 grams. You just take it out yourself. Just multiply these, and then you must get 20 grams as the answer. And now the same thing. Find the mass that is required to prepare. The next question, question number 7. I'll change it. The next question for you is find the mass of it is required to prepare. It is 500 ml, right? Prepare 500 ml of, this is this time 500 ml of 0.5 molar in a solution. Yeah, the 7th one. And then the final answer here, it turns out to be, your answer here should be, if I'm not wrong, it is 10 grams. You just see whether you get this answer or not. And finally, the last and final one. Here, view question number, the last problem here with regard to molarity. And next, we'll pick up molality, right? Okay. Right, question number 7 there. Question number 8. Find the mass of sugar C12 H22 O11. This is O11, no? required to prepare it is 20 liters of 0.025 molar sugar solution, right? Very good, sugar solution. Right, so this is the last one for you. And here, the answer, if I'm not wrong, it is 171 grams. That's it. And now the last method here of expressing the concentration of a solution is the molality. Now, this thing of molality, the fourth method, it is called molality. L-I-T, molality, right? Molality. Now, molality, it is defined as the number of moles of solute or salt present in 1 kilogram or 1 kg of the solvent, not the solution, of the solvent. So here, the expression is molality of a solution is given by number of moles of the solute, divided by mass of the solvent in kilograms or in kg, right? In kilograms. So here again it's the same thing. In the numerator you have the number of moles of the solute, that is a salt, and then in the denominator you have the mass of the solvent, not solution. So you have to find the mass of the solvent, and it has to be expressed in terms of kilograms. That's it. So based on this, just maybe two simple examples. Okay, the very first one for you. Example number 1. The first example for you is okay, a direct one. Find the molality of a solution prepared by dissolving. Okay, it says 10 grams of NaOH, 10 grams of NaOH in 2 kilograms of water. That is 2 kg, 2 kilograms of water. Now this is a very simple one. So you need to find the molality this time. It is not molarity, but this is molality. So find the molality of a solution prepared by dissolving 10 grams of sodium hydroxide in 2 kilograms of water. So here you are given this sodium hydroxide, your salt, in grams. So you need this in moles. So first you write number of moles of NaOH, your salt. It is 10 grams, right? So number of moles is given by dividing the given mass of the salt by its molar mass. So divided by its molar mass, you get number of moles, right? You got it. If not, you can use that unit factor. So if you talk about sodium hydroxide, I want this in terms of moles. So 1 mole here of sodium hydroxide is nothing but 40 grams. The 2 G's, gram, they get cancelled. So it is finally 10 by 40. So 10 by 40 is nothing but 1 by 4, it is 0.25 moles. So this 10 grams of sodium hydroxide is the same as 0.25 moles. And then mass of the solvent, you are given mass of the solvent or water, right? Mass of the solvent, that is water, is 2 kg or 2 kilograms. And then now you can straight away write the molality of this solution. Now the expression for the molality of the solution is, okay, so you just write molality of this solution. Molality of the solution is number of moles, it is 0.25 moles divided by mass of the solvent alone. It is in terms of kilograms here, it is 2 kg. So when you simplify this, it is 2, 5, 25, 2, and add 2 zeros here, mole by kilogram, right? So when you divide this, I'm going to get 5 times, that's 1000 125 by 1000. So it is 0.125 moles per kg. That is the correct answer. So the molality here, 0.125 moles per kilogram, this is the correct answer. So in the same way, I'll give you one problem to work out. Find the molality of a solution prepared by dissolving. Second one for you, the second one. Find the molality of a solution prepared by dissolving. And this is in terms of moles, right? Right. 0.2 moles. 0.2 moles of sodium chloride in 750 grams of water. In 750 grams of water, that is H2O, right? Now this 750 grams of water, again you have to convert this into kilogram. It becomes 0.75 kilograms, right? And this is fine. Molality, dissolving 0 moles of sodium chloride. So this is the number of moles. You are given the number of moles here. You can directly take this and then solve. So the final answer here, it is 0.235 moles per kg. If I'm not wrong, just check it out yourself, right? 0.2 moles of NaCl, fine. 750 grams of water. Now the last type here, the final one. Okay. This is to again find the molality of a given solution. But here you are going to be given the density of the solution. The density of the solution. Now, you know the expression for density. Density is given by the expression density is equal to mass divided by volume, or density is equal to mass over volume. So now this is the last type of problems here. Question number 3, this is example number 3. So it says the density of a 2 molar solution of sodium chloride is, it says it is just 1 gram per ml. 1 gram per ml. Calculate calculate the molality. Calculate the molality of the solution. Calculate the molality of the solution, right? So this is the last one for you now, and then I'll give you one problem for you to work out. Now here it says something about density. Density we know is given by, density is equal to, see, density is given by mass over volume. Mass over volume. So here we're talking about solutions, and here when I say density of the solution, it is a density. Density of the solution means it is mass of the solution divided by volume of the solution, right? Mass of the solution divided by volume of the solution. Now, let us see how this can be applied here. So what you've given here is 2 molar solution. When I say 2 molar solution, that is the molarity of the solution is 2, which means you have 2 moles. 2 moles of the salt, that is sodium chloride, present in 1 liter of the solution. 2 molar solution means 2 moles of the salt present in 1 liter of the solution. If I say 1 molar solution, then you have 1 mole of the salt present in 1 liter of the solution. Everything in 1 liter. If I say 0.5 molar solution, means 0.5 moles of the salt in 1 liter of the solution, right? So let's see. This 2 molar solution, right? You can now write, since it is a 2 molar solution. 2 molar solution. Since it's a 2 molar solution, you have, since it's a 2 molar solution, there are 2 moles of NaCl in 1 liter. Keep this in mind, right? Since it's a 2 molar solution, there are 2 moles of NaCl in 1 liter. Now, see, this is the number of moles of NaCl present in 1 liter. Now, we need to find the mass of 2 moles of NaCl, right? So, mass here of 2 moles of NaCl is equal to, I'm going to do this 2 moles again, making use of this unit factor. This is sodium chloride. Sodium chloride. You know that the molar mass of sodium chloride is 58.5. So I want to find this mass in terms of grams. So it is 58.5 grams divided by 1 mole. This is the unit factor I'm talking about. See, 1 mole of sodium chloride is 58.5 grams. Or 58.5 grams is the same as 1 mole. Or this is 58.5 grams, 1 mole. They get cancelled finally. It is a unit. It becomes a unit factor. Mole and mole get cancelled finally. Mass in terms of grams is going to be double this. So it is going to be 100. I think it is 117 grams, right? So this is the mass of NaCl in your solution now, right? Okay, the next thing you are given is now, you are given the density of the solution. See, density we know is mass of the solution divided by volume of the solution, right? Now, this is mass of the solution. We are talking about the solution here, divided by volume of the solution. Volume of the solution. So here the volume to be considered here is 1 liter expressed in terms of milliliters. So density, because it's given in terms of grams per ml. So it is density is 1 gram per ml. Mass of the solution we don't know. We're going to take it as X divided by mass of the solution. This overall mass of the solution is not given. So volume of the solution, you take it as 1000 ml. So finally when you cross multiply here, X is equal to 1000, right? So you can write this is the mass of the solution, right? or you can just leave it as it is, right? Take it this way. This is your mass of the solution. Mass of the solution, overall solution, right? Which includes the mass of the salt and the solvent. So when you cross multiply, your mass of the solution here is equal to 1000 grams. So 1000 grams is the mass of the solution. Now what we need is to find the molarity. You need the number of moles of the solute divided by mass of the solvent alone in kilograms. So the next thing is, this is the mass of the solution, which includes the mass of the solute and the solvent. Means both the masses of both the solute and the solvent are included in this. So what is the mass of the solvent alone, that is water? Now for this we have found the mass of sodium chloride, that is in 1 liter of this solution, it is 117 grams. So mass of the solvent, that is your water, is equal to mass of the solution, right, minus mass of the solute. Mass of the solution minus mass of the solute. The solute here is your salt, sodium chloride, right, it's here. So mass of the solution, you have found it to be 1000 minus, that is 117 grams. And finally this mass is 883. Let me do it fast for you. It is 883 grams. It is in grams. Now if you express this in terms of kilograms, you got to divide it by 1000 and it becomes 0.883 kilograms, right? So finally you now have to find the molarity. Therefore, I'll just put it here. The molarity of the solution now. Molarity of the solution here is equal to number of moles of the solute. Here number of moles, it is, since it's a 2 molar solution, you're taking 2 moles of the salt in 1 liter. So you got to put 2 here, divided by mass of the solvent in kilograms. After working on all this, after doing all this, you found the mass of your solvent, that is water, to be 0.883 kg. This is in terms of moles. So you need to divide now. You need to divide 2000 by 883. It is moles per kg, right? So finally when you divide 2000 by 883, it is 2 point something. Yeah, I've got it to be 2.265 moles per kg. Moles per kg. And the short form here for moles per kg, you can write small letter m. That's the convention, 2.265 m, which means moles per kg. And now one last problem for you to work out. Maybe this is number 4. It's this one. The density of a, change this to 0.5 molar solution of, it is NaOH now. NaOH is 1.1 gram per ml. That's it. Then calculate the molarity of the solution. So you can just apply the same sort of methods or the rules here, and then you can finally get the molarity of this solution. So this is problem number 4. Okay, that's it. So thank you very much. Thank you. That's it.